Today we're going to speak to you on what we're doing with Aruba CX switching. The topic we're going to focus on is business resiliency and helping our end customers design networks that are with high availability based on the technology that we're able to build. So I'm Ed Chang. I lead product management for the campus switching team. And with me, I have Yash, who is our lead TME team member, managing the whole switching TME team. And then finally, Anoop, who is our PLM focusing on many of the features that you'll be hearing about today. So what is business resiliency? This is what end users, when they design their network, they want to make sure they have very high uptime. They want to build it so that their workloads are accessible by all the users. And of course, all the users and devices and things get connectivity to where they need to go to. And there's many ways to build a business resilient network. You see on the right-hand side, there's certainly management and operations where they decide how to configure, monitor, deploy their network assets. There are ways to make use of physical redundancy, and that is both within the network assets that are deployed, like physical redundancy within a switch, power supplies, management modules as examples, as well as the physical network itself, deploying dual systems, one as primary, the other as standby. Then there's also logical design. When you're doing routing protocols, you always have multiple paths to make sure that there's redundancy within the network. Disaster recovery, where in case a site goes down, you have another site as that backup. But today, we want to talk about how we can help these end users with software redundancy, or in the specific case, software updates. And one of the key pillars for us to help end users in software updates is the CX software operating system built within our switches. It is a common operating system across all of our portfolio, from campus to data center. And there are some key tenets in there that help us enable this high resiliency to help customers when they want to do upgrades. And as you know, software upgrades, typically downtime is required. You have to reboot the switch, you have to load the code, and this has a cost to the end users. What we want to do is minimize and even eliminate this downtime when they're upgrading software. So within the operating system, it is a microservices architecture. So each process is running independently. Think of routing running independently from VLANs, running differently from QoS. We have separate databases that keep information on state, as well as performance series database that keeps information about what's going on within the switch. And all of this is accessible by all of these processes that I mentioned. And each of this is accessible by the user to either configure, monitor, or to check status directly on the switch itself through APIs or through our Aruba Central management system. So as mentioned, within our architecture, there's many ways to do redundancy. And you see in the black boxes some examples of physical redundancy, like stacking, clustering, or hot swappable ports, or line cards, always on PoE. Then there's some management and configuration that we can also help you with built-in analytics for redundancy. But on the software side, we have a number of innovations that are available today that we'd like to share with you. VSX, which is for a dual chassis-based system where we do live upgrades. For those of you who are in Atmosphere, I think 4 years ago, we did a live demo. We showed 2 of our 6400s. There was a presenter presenting while the systems were rebooting, and it was live. There was no downtime while that was being done. And that really leverages the databases as well as the independent microservices that we have. The next thing, which are new but available, is hot patching. We'll go into some details of that and how we do that. And then ISSU, how we feel we do that and help customers upgrade software within their system. So first off is hot patch. And as you recall on the previous slide, we leverage the microservices architecture within our operating system. Each service is running independent of each other. And when there's an issue, let's say there's a bug in routing, some customers ask us to fix that bug, but they don't want to reboot the whole system, reinstall the whole image. They just say, give me a patch, fix this issue for me. So what we do is, in a hot patch, we look at critical updates, whether it's a bug or a vulnerability. And I'll continue with the routing example. The customer calls in, we do an update to the code itself, and then this code update, the customer is able to install without a reboot of the system itself. And then they can leverage this information for any future code, normal code updates, which we do frequently on a monthly basis. So any bugs get rolled into future releases that not only this customer can take advantage of, but of course any other customer can take advantage of itself. So the benefit is we fix what you want fixed. And you can install only that fix in your network itself. It's quick turn. So if the customer calls in, it's causing me a problem, I need this fixed, then we go ahead and put that fix in and they start installing it. And as I mentioned, no downtime and rolled into the next release. So then the process is they call in, we identify it, we create a patch, we give them an image, and then they update this. So this is for vulnerability and bug fixes. We then leverage this technology for ISSU, which is in-service software updates. The in-service software updates not only fix bugs and vulnerabilities, but of course include feature updates. So this is part of our normal code updates that happen on the frequency I mentioned earlier. And customers can choose to update software. And typically in an update of a software, there's a maintenance window and there's some downtime scheduled. What we have done is to help customers in chassis-based systems first to update that software without a reboot of the system itself. So you see the benefits. They maintain their connectivity. The endpoints still stay connected during the entire upgrade process. And of course, we roll this any updates to future releases that they can use the ISSU process to update again. And what we'd like to do is share with you a demo of how we do this. So I'm going to let Yash finish with the rest of this slide and then take you through a demo.
As you know, Aruba 6400 get deployed from all the way from access, aggregation, and core. Each one of this upgrade process have to be zero downtime because they deploy in hospital environment, because to get their cameras up and running, each cameras have their own significance. Think of it like an ICU environment where the critical data is passing from one of the patient bed to a data center, and each one of these frames are so important and you cannot miss any bits there. And we have to upgrade in those cases. There is no downtime we can expect, right? Because you need to upgrade the whole that hospital, especially those centers where 24/7 required. You need to upgrade the software also because there is no downtime in 365 days. So how we achieve this is really a great process. And I'm so proud on the ISSU process, what we do on the 6400 chassis. Before I walk you through the demo, I just to make use of this hardware. It's kind of a way we call it as a management module, and some of the other companies call it different ways. Basically, this is where the brain of the overall 6400 stays. And also there is a database, as Ed said, and it has microservices. What does it mean is every daemon which is talking to the database is a separate daemon. STP is a separate daemon, OSPF is a separate daemon. Every daemons are separate. And as you know, Linux make use of the binaries to build those daemons. So what we are going to do is we will make sure those daemons are going to be swapped. How we are going to swap it is through the lot of hard work, and thanks to the overall PLM team, highly experienced folks from seeing the world of other vendors. What they have done is they have looked at the whole current model, how they upgrade. We just go and swap those binaries from the overall software angle. So we swap it and restart those daemons without having any impact to the data plane. You are going to see that one on our 6410, which is the biggest platform which you can think of on an Aruba CX portfolio. It's a 6410. That means it can have 10 line cards on a 6400 chassis with 2 management modules. I would like to stress on this 2 management module. While I walk you through the demo, you will see a beautiful things which are happening on the Aruba CX management module. These LEDs are going to be so nicely, you are going to see it now because I've connected one of the 4K camera to the same 6400, which show you guys how the process happens and how we are going to freeze that database while we do the data plane complete upgrade and then go to the control plane upgrade. Let us see that one as a demo as part of this one. I'm using a 6400 fully scaled chassis, and we have an innovation zone which we are going to show live. Yesterday, a lot of customers, they really loved that one. We have video frames, 4K video frames connected, live video. We do the software upgrade then and there itself. You can watch that one, it's hitless. For the time's sake, we have a CAN demo, which we're going to show you now.
I understand you're not bringing down the switch, but you said you are freezing the data plane.
Yes.
So you are freezing data being processed.
Yes,
right? Where you make the control.
Very
the
nice
change,
question.
right?
So when I said data freezing, it's basically database freezing for the data plane to not to accept any more fib or a rib entries back to the ASIC. That's what we are freezing, so that whatever you already programmed, let's consider I'm communicating to a default route, those all things are not getting disturbed at all. Whatever you have done a 1K routes or a 2K routes, whatever it is running, they have no disturbance at all. Let's walk that one through while the demo is going through. As you see on the screen, the top one is the active management module, and below is the standby management module. And we are sending a full line rate of traffic. That's what the Ixia. And the below is the same 6400 what you are seeing, which we are doing upgrade. Now you can see this one. This has a 8K IPv4 v6 and a 20K MAC address and 20K ARP entries on this box. And we are going to do a clean switchover. How it's going to happen, let's watch this one. As you are watching this one, currently what's happening, you can see the first step is we will check whether the ISSU is ready or not. This is done so beautifully. Is basically you check all the ACL TCAM entries on the active and a standby are all synced or not. That's a very important, because that's what happens on the data plane. And the next step we check is the images, whether the active image and the target image are same. What we want to upgrade on the standby and the management module are exactly working the same or not. Like let's consider 10.11 and 10.11,000 you want to upgrade. We have the exact images on both. We check that one before we kickstart the overall process, because that is the key to give green signal for us. Okay, you guys can go ahead with the ISSU process. And that's what it's happening. As I'm talking through, it's validated, is complete. The standby module, I don't know you observed this one, there is a nice signal about these two LEDs, you can see. And now standby is getting another signal, which got third LED that started blinking, because from active management module, it got a signal. Hey, you know what? I'm going for an upgrade. Let's get that signal and let's start the upgrade process. You see now, some of the line cards, because we froze those database, data plane is not impacted at all. Everything is going on a full line rate, and the database sync happened to the standby. You can see some of the LEDs are going down from the management module of the active MM, and it's going to the standby. The overall process is taking place while it's syncing the database also. There is no impact on the database at all, right? And you can watch this one. Now the standby module complete, but still every traffic is going through still the active management module. Though that it's upgraded and had that complete database sync, it has not done the switchover. Why? The reason, because all the line modules are getting upgraded to the new latest. How we do that one is a beautiful thing. We just go and look at the binaries and swap the binaries with the new one. Stop the daemons, change the binaries to a new image, and the line cards will continue to ship the traffic with no impact, because they had no change. Once the line modules upgrade is done, that means all the 9 modules of the 10 modules are complete. And standby knows it is completed. Line modules are upgraded to 10.11,000. That means now the overall, the standby is ready to take over. While standby takeover, there is a two-step process. One is how are you going to sync the database of the control plane as well as the management plane. So there are two databases, correct? Because when you are seeing, there may be a STP flap. Is the STP flap, can I go and impact? That's not going to happen. As you see now, the active took over, the standby is now booting, right? LED, watch the LEDs. Now you have only 2 LEDs on the management module. It's waiting for the signal from the standby. Can I go and take over back, saying that can I go and boot the 10.11,000? That's what it's waiting for. And you will see in a minute the third LED will blink, and that's it. So that means active took over to the 10.11,000 with no impact. You can see the video which is connected on the same chassis had no impact. And the overall traffic, it's a 0 loss. And all the frames are no impact at all on the overall network. And that's a process. And when you want to watch after this, maybe when you get up, you can see the LEDs so that you know exactly what we went through.
Thank you, Yash. So as you saw, ISSU on our chassis-based system, which is our largest campus deployment system that's available for customers. So the next question from users. Well, what are you doing on the stackable switches? Because we also deploy stackable switches within the network. But we have also ISSU capability. We're calling it enhanced software updates for end users on the stackable based systems itself. And just a reminder on the stackable systems, on the enhanced software upgrades, this is what's called enhanced software upgrades for our stackable switches. As Yash showed, there's always upgrade for software that comes along. And in a stackable system, we have a conductor, which is the primary. We have a standby, and then we have members. Each one of them is an individual switch, but acting as a stack. And when the software update is required, if you have, say, 8 switches in a stack, you'd have to upgrade each switch individually. There's going to be downtime, which is service impacting for our customers. So we have enhanced software updates, which will help you upgrade the members and the standby with no hit in the performance or the data going through. Only the conductor, which is the primary, that has to reboot when it gets the software update. So within the process, which Yash will again show you a demo, very similar to what we did on the chassis-based systems that showed the primary and the secondary and the failback when the software is updated and the control plane is getting the software update, but the data plane continues to move. So again, I'm going to turn this back over to Yash.
ESU is also enhanced software upgrade. We are not calling it as a ISSU because ISSU is a hitless, and we want to achieve that one for environment where they have deployed the chassis switches. In this release, we are calling it as enhanced software upgrade. The enhanced software upgrade is also done as it briefed. The standby is a complete set of ports. You have a PoE connected, cameras are there, and also all the members are connected to a lot of systems which are needs PoE. For example, you're connected to an end of sale machine. And these all applications, whatever you're running on the end of sale machine, are also critical. You don't want to have any downtime on the stackable switches also. So as yet briefed, standby and the members will not have any impact, zero downtime. Because conductor at the last step, what you saw on the ISSU, the management module was rebooting. Here the conductor, whatever the clients are connected on that will only have an impact for 10%. Let us watch that one through the video. This is also, I brought full scale setup similar to what we did on the 6410. Similar to 6410 full scale on the ESU also. That means we have a 10 stackable switches, 6300. We have connected all of them using Aruba VSF, front plane stacking, and we are going to demo that one in front of you. The full scale setup now. This is the overall process we explained already. Let's go and watch this video. This is also the conductor, and that's a standby. And one of the member is connected with the internet video. So we are playing a YouTube video which is connected to one of the member 3. And during the overall process, the standby or the members should not have any impact. The impact should be only for the conductor. So let us watch that one, how it's going to go through. As you are watching, this is a full scale setup, which is a 10 member VSF stack, and it has 5K MAC count, and it has almost, you can see there's a 1K ARP entries on this switch because it's access stackable switches. In the access layer, this itself in a multi-dimensional scale, this is a huge one. So, and also it has number of routes, and you can see the summary. It's a 1K route for IP v4 as well as v6. Similar to what we did on the 6400, we are going to execute the same command here, ISSU software upgrade. The process exactly continues the same way. We are going to first upgrade the standby. While we upgrade the standby to a new image, it validates the exact same checks. What are those checks? Verify the QoS, verify the ACLs, because they are installed where? They are installed on the data plane. That means your ASIC has those all entries. You need to be 100% sure they are not failed at all. You should not have any ACL entries on the standby. Let's consider I'm sending some routes. If the ACL entries are changed, you know what's going to happen on the network. So that's a very crucial one. We take it very seriously because security is so important. So we make sure that the standby has all of those QoS and ACL entries exactly same. The next process, as we briefed, we check the image, active image on the conductor as well as the active image on the standby. Okay, both are matching. What is the next step? Okay, where you want to upgrade? Okay, let's consider I'm upgrading from 10.10 to a 10.1000. So I'll check, okay, both they have the 10.1000, then validation is complete, it gives me a green signal. Once the validation is complete, I will also check, can I do a database sync? That means I'm having all the database entries now on the conductor. Can I do a complete sync onto the so once the standby boots properly, as you see, now the standby is booted so quickly. That's what the innovation I call it as Aruba CX. I think engineering team has really worked hard on all of this. So standby has already booted and it had the sync coming from all the way from the primary, that's a conductor, to the standby. Databases are complete. Now what it's doing, it's checking the members. You can see the video, there is no drops at all. The video frame is what very important, because anytime you can check on the Ixia, there may be a delta of frames, but the application impact is very important, because application impacts is like 300 millisecond. If you have a more drop, then the application will get impacted. But you can see there is no impact at all. All the 9 modules are getting, the members are getting upgraded to a new 10.10,000, right? And the same process, once that is done, now you can see it is going on rebooting the conductor. It gave a signal. I don't know if you watched that one. I'm connected on a console to show you every signal. It showed the signal saying that I'm going for a reboot. This guy goes for a reboot. That means there is an impact on the conductor today. So if you have a clients which are connected onto the conductor, they will have an impact. No impact on the standby. No impact on all the members. 0% loss on the application.
Does that include PoE loss?
PoEs are not impacted at all if you're connected to standby and the member.
But the conductors would lose PoE?
Yes. PoE, there is 2 features on the PoE. We call it as a quick PoE and always on PoE. If you have connected them, the quick PoE will not lose the power to that PD. That means PD will be up, but it will not be doing the data plane.
Question on the with the hot patching. One question that's kind of floated around is, since you're targeting patching of a very specific module, how much regression testing is actually being done to ensure that you're not impacting other functions within the system?
Beautiful. That's, as I told you, to claim the hitless on ISSU, we do every type of customer. We have something known as customer information repository with all our segments, whether it is verticals of hospital, retail, everything. So every customer, we run through this test with complete maximum scale and make sure that every daemons have no impact. Like let's consider the OSPF control plane itself, we check a lot more times, and then we go for a data plane validation. While we do the data plane validation also, as you know, it has a various things IMIX traffic. For example, if you take a 64 frame, sometime we'll have this kind of claim is a very hard claim, ISSU with a hitless, right? So 64 frame size, for some application, we might have impact. So that's what we looked after every angle and make sure that those have 0 impact. There is some concern about multicast. People will talk about it because multicast leaves and joins are so frequent. Suddenly, there is a football match. Everybody tuned to that channel, right? So the leaves and joins, how are you going to update the line card? That's what I was talking about as Madam asked. So we are going to freeze the data plane. That means whatever entries were there when I'm starting the ISSU process, for those sessions, there is no impact. But if there are leaves and joins on the control plane level, they stay there till the ISSU process is complete. So that's beautifully we have done it. And that's true for the tunnel users as well as for the multicast users.
So I have a question for both ISSU and the ESU. When you're complete, your conductor moves. Do you move the conductor back to the physical original conductor? Or in your previous example, do you have that master go back?
That's also a very good question. So in the current environment, we have no difference between the conductor and a standby. So as it's an admin who has to decide, when I'm deciding a 48 port as a conductor, I will also decide the standby as a 48 port. So that means new standby is the conductor and it will stay there. In case if you want to roll back, there is a feature which you can roll back and you can make the other one, the previous one, you have to execute one more time the ISSU or one more time the ESU. That's all. But no impact at all.